Hi everyone, and welcome to the Mat 211 review of Measures of Central Tendency. My name is Julia, and I work for the tutoring centers at ASU. So the following is a table showing the population distribution of citizens of a particular town grouped by age. So we've got age here, we've got age ranges, so 0 to 99.9, 20 to 39.9, and so on. And then we have the associated populations of each of these groups in the hundreds. But we just reduce them to numbers, easier numbers to work with by dividing out the hundreds and all of those. So we want to use the rounded midpoints of each interval to determine the probability distribution table of the age X of a citizen. Then we want to compute the expected age, or E of X. So first, let's talk about setting up this table. We want the rounded midpoints. So what that means is for each individual group category, so let's start with 0 to 19.9. We're going to add those two values, so 0 plus 99.9, and divide it by 2 to take the midpoint. So this is the same as averaging those two values. This will give us 9.95, and we'll go ahead and round that up to 10 just to give us a rounded midpoint as they request. So we're going to do that for each of these. So this one will become 10. We've got for 20 plus 39.9 divided by 2, that one becomes 29.95, which is approximately 30, and we'll go on like that. So our table will end up having a 10, a 30 for this one, a 50 for this one, a 70, and a 90 for that one. So you can go ahead and verify the rest of those average midpoints yourself. So let's go ahead and write that in. So our table will look like, age, and that's going to be, so we'll have a 10 for the first one, a 30 for the second one, a 50 for the third one, that's a 50, a 70, and a 90. Now, we want to figure out what the probability for being in each age range is. And we're assuming that, no group is weighted differently than the others in terms of, the likelihood of being in any one of those. So we're just going to assume that it's going to be the frequency of each group divided by the total number, which is the same as calculating probability as the cardinality of a particular event, say being in this age range here, divided by the cardinality of the sample space, which is just the number of total values in the sample space. So let's figure out what this is. The first thing that we want to do is figure out how many people are in the town, which is going to be the cardinality of our sample space. To do this, we're just going to add each of these values, 18, 15, 8, 3, and 1. So that gives us 18 plus 15 plus 8 plus 3 plus 1. And that's going to equal 4,500. So remember that this is in hundreds. So now we can go ahead for our probability, which we're going to say the probability that big X is equal to a little x here, where our little x is our midpoint age. We're going to go ahead and take each one of these frequencies, so 18 here, that's the number of hundreds of people in, with the associated midpoint 10. And we're going to divide it by the number of people in the population. So for this first, we'll get 18 over 45. And remember that, this would be in hundreds, but the hundreds divide out here because there's 100 on the top and 100 on the bottom. So we can just ignore the hundreds for here. Our second would be 15 divided by 45. Then we have 8 divided by 45. We have 3 divided by 45. And lastly, 1 divided by 45. Oops, and I wrote a 1 there instead of a 5. Said it right, wrote it wrong. There we go. All right. So now we've got our probabilities. And so this is our probability distribution, this guy on the left here. Let's clean up my scribbles here so we can see what we're looking at. Now we want to calculate the expected value of our big X here, where our big X is the age X of a citizen. So remember that expected value of X is equal to the sum from I equals 1 to n, where n is the number of different possible values of little x. So in this case, 5, because 1, 2, 3, 4, 5. So let's just go ahead and write a 5 instead of our n there. And then we're going to multiply each value that little x can take. We'll say xi here, since it's indexed, by the probability associated with that value. So that's the probability that big X is this small value xi. So what this means is that we're going to have 10 times our 18 over 45 plus 30 times our 15 over 45 plus 50 over 8 over 45, or times 8 over 45, plus 70 times 3 over 45, and lastly, plus 90 times 1 over 45. Now, we can put this in our calculator or however you choose to solve, but we find that this is approximately equal to 29.6 years of age. So, given that we're using the rounded midpoints of each age interval in our population here, we expect that the age of a randomly sampled individual, X, the age X of a randomly sampled individual is going to be 29.6 years of age. Notice that this is not in our distribution here, but that's okay because oftentimes our expected value is not actually one of the values that our variable X can take. So let's clean this up a little bit here and then we'll box it up. Oops, lost our line, that's okay. We'll just put that back in a second. There we go. Put our line back. All right. So, in sum, this is our probability distribution. And this is our expected value of X. So that's it. Before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring services for your specific course, you can use our tutor search tool, which you can find on our main website page here, or by going directly to the link on the screen here, which will take you right to that tool. So thanks so much and have a great rest of your day.